One, two, three.
What's up, team? Today we're going to do some factoring by grouping. Learning target says I can factor by using the grouping method. This method here is, conceptually it's not that crazy, but when you're in the thick of it, seeing it for the first time, it looks really weird. It looks like a little math magic. It looks like it's almost kind of cheating. So I'm going to do my best to explain not only how to do it, but why it works. So let's just dive right in. We have this polynomial here, x cubed minus 5x squared plus 3x minus 15. And there's no greatest common factor between all four of these terms. We can't unfoil it because it's not just a quadratic. We have this x cubed term. So we're going to use this new method that we're going to be talking about today, factoring by grouping. So we're going to form a couple groups within our polynomial. Both of these groups happen to be binomials in this particular case. So we have this group in blue, x to the third power minus 5x squared, group in red, 3x minus 15. And we're going to look at them individually for just a moment, see what we can see, and then we're going to bring them back together and see how they relate after we work with them for a minute. So the first group is this x to the third minus 5x squared. I'm noticing that there's a greatest common factor here. They both have an x squared, both of those terms. So we're going to factor out that x squared. And when we do so, in parentheses, we're left with x minus 5. Okay, cool. We're going to put that on hold for just a minute. Let's examine the other group, where we have a 3x minus 15. And these also have a greatest common factor. This time, the greatest common factor is 3. So we're going to pull out that 3. And when we do so, we end up with an x, then negative 15 divided by 3 minus 5. There it is. Cool. Let's smash them back together like what we had, because earlier we had red stuff plus blue stuff. So we're going to have, again, or I guess it was blue then red. Doesn't really matter the order if we're adding. So we're going to set it back up again. X squared times x minus 5. And we're adding that to 3 times x minus 5. All right. Well, these two things have something in common. Clearly, they have this x minus 5 in parentheses in common. I'm wondering if there's anything that we can do with that. So let's look at an example, just kind of on the side. This is brand new. We're putting this on pause for a quick second. Here's an independent example. Say that you were given something like 2x plus 3x. Well, this is kind of similar to what we're working with, but instead of x's in common, we have an x minus 5, and instead of 2 and 3, we have an x squared and a 3. Well, I think all of us would quickly say, well, 2x plus 3x is 5x, but what we've done with this in our heads, and we've been so conditioned, is really what we're doing is this 2 plus 3, and we're throwing it in parentheses, and we're multiplying that sum of 2 plus 3 times their common factor of x. Maybe we haven't used that language because when we're learning this stuff early on, we weren't talking factors necessarily, but that's really what's happening here. And of course, 2 plus 3 is 5, so it's 5x. We're going to use this same idea down here. And again, instead of having an x, we have an x plus 5, and instead of a 2 and a 3 that we're adding together, it's an x squared plus 3. So check this out. We're going to have an x squared plus a 3, and I'm going to throw that in parentheses. So x squared plus 3, because that 3 is positive. And then in parentheses here, I don't really know what color to use because it's both red and blue here. So we have our x minus 5. And these two binomials are being multiplied together, which again feels a little foreign. It feels a little weird because up here we added and subtracted everything. And then all of a sudden we end up with these two binomials being multiplied. Well, the reason for that is, again, it's this side example here. When we had 2x plus 3x, well, we took out the 2 and the 3 and added them like this, and we multiplied them times the stuff they had in common. In this case, it was x. Here it's x minus 5. So this is how we would factor our kind of gross polynomial up here to look like two binomials that are being multiplied together. So sometimes it's easier to look at the expression like this. Sometimes it's easier to look like how we started with. It just kind of depends on context. But this gives us a tool to be able to factor a polynomial that looks like this one. Okay, let's look at one more of these. 4x cubed plus 2x squared minus 2x minus 1. Again, split them up into a couple different groups here. Blue group, red group. 4x cubed plus 2x squared. Well, these have a 2x squared in common, so I'm going to factor that business out. So this is going to leave us with 2x. And if we take a 2x out of this, we're just left with, or 2x squared out of this. We're taking the whole thing. So we're left with a 1. Okay. Let's look at our red group, see what we can see. Negative 2x minus 1. Well, these ones, technically they have a negative 1 in common. So let's pull that out and see what happens. Multiply or divide this by negative 1. We learned that this is 2x in parentheses. Divide this by negative 1, and it turns into a plus 1. Okay. The fact that we have a 2x plus 1 in parentheses in both these shouldn't be much of a surprise. That's going to be a tell for like if you factored by grouping correctly, or even if it's worth your time. If you try this a whole bunch of times and you can't make these match, well then that tells you this isn't a problem that can be factored by grouping. All your practice problems can. There's no surprises. There's none that say like, oh, you can't do it. All of them can, and this one can as well. So we're going to do the same sort of thing that we did down there. Actually, let's smash it all together. 2x squared times 2x plus 1, and then we have a minus sign out here. So minus 1 times 2x plus 1. And just for that, I'm going to throw the equal sign out there because this original polynomial has the same value as this one that is grouped. Now, this is the key part, right? This is when we had that 2x plus 3x stuff, but obviously it's a little bit messier than that for this particular one. So we have our 2x squared, and then the coefficient on the other side is a minus 1. So this is going to be our outside, or our first binomial, I guess. And then the second one is the stuff on the inside, the 2x plus 1, that they both have in common. There we go. Factor by grouping. If you are someone that might not be convinced, like, oh, this is some math magic, this isn't working, you could go through, take these two binomials, FOIL them first, outer, inner, last, and you will see that when you're done with that, you'd get back to where you started. So these two expressions have the same exact value. Of course, it's the same over here as well. If you FOIL this, you get back to where you started. Okay, let's dive into some practice problems. You got this.